Hello, this is exercise 2D.1. This is for Year 12 Further Maths. And what we're looking at here is something called the scalar or dot product. Now you should know the product of two things is what you get when you multiply them together. So I suppose since we're dealing with vectors, this is all to do with vector multiplication. But it's a bit weird. For instance, if I was doing vector multiplication and say I had a vector here, 2, 4, and I wanted to times it by 3, 5, say. Well, I'd want the answer to be 620. But unfortunately, this is not the answer. This is total rubbish. So just bear in mind that vector multiplication isn't as obvious as you would perhaps assume. And I'll go through now one of two methods of multiplying together two vectors. I mean, the mere fact we've got two vector methods, it kind of implies that I know that perhaps it's not obvious. Well, clearly not, because the obvious one they don't use. And the reason why they don't use it, it turns out this isn't useful. So why do it if it's not useful? So effectively what they've done is, over the years, they've found a couple of methods which are useful. When you multiply two vectors together, the answer, the definition they come up with, turns out to be useful. And here's our first one. Well, the first one is really comes from the name scalar. This is to do with a scalar is anything but a vector. It's like a number, a normal number. So the answer could be 4, 3.6 or 2.5, but it's definitely not a vector. And what they do is, if I have two vectors, A and B, and I know the angle in between them, the angle in between them is important because it allows me to do what I'm about to do. I'm going to define the A dot B to be equal to the length of one of them, which is A, times by the length of the other one in the direction of A. Sounds a bit weird. Now if I just think of this as like a little right angled triangle, this is the opposite of the right angled on the angle. This is opposite, and this is obviously the adjacent side here. And I suppose what I would do is I would say to myself, well, what is, well, I mean, I'm looking at this here and I'm thinking this is hypotenuse. Okay, well, bear that in mind. I reckon cos theta is the useful one. Because the useful one is because it's the adjacent over the hypotenuse. And I did say I wanted this to be the length of this red line times by the length of the black line almost. So the cos theta here would be equal to, let's just think, it's the length of this here, which I don't really know what it is. I'm just going to stick with the adjacent, divided by the length of this line, which I do know what it is, the magnitude of B. So what I'm getting at here then is I could rearrange this and I could say, well, the adjacent must be equal to B times by cos theta. And therefore, if I was to multiply the red line by this black line, I would have this formula. I'd have this A dot B is now equal to A times by B cos theta. And it's not really A because it's the magnitude of A. It's the magnitude of B cos theta. This is the formula that we use. And notice what I do. We call it A dot B. Don't put a cross there because there are later on when we times two vectors together and we put a cross and it means something completely different. So A dot B is AB cos theta. Bear that in mind. The dot must not be missed out. It produces a scalar answer, not a vector, and it's called the dot product. And that explains what it is we're trying to do. Now, let me give you an example of this. It's a three-dimensional question. It says, given that this and the angle between them is, oh, that's a bit accurate, isn't it? Find A dot B. Okay, then let's do that. Well, A dot B equals, well, notice what I do here. I have to find the magnitude of both of them. So let's find that over here. The magnitude of A is the square root, and this is where we use Pythagoras, 1 squared plus 2 squared plus 3 squared. Ignore the minuses. What's that? It's 1 plus 4 is 5. That's root 14. And interestingly, the magnitude of B, I've deliberately done it so it's the same numbers. It's 312, so it's 3 squared plus 1 squared plus 2 squared. So it's root 14 again. So, okay, so that part of it is easy. A dot B, therefore, is the magnitude of one times by the magnitude of the other times by the cos of the angle in between. 77.63. So I'm going to get my calculator and I'm going to type that in. Make sure you're in degrees. Yes, I am in degrees. So it's root 14 times root 14 is 14 times by the cos of 77.63. I get 2.999. Well, I'm assuming that 2.999 was meant to be 3. And in fact, it was 3. Obviously, if I'd done this angle even more accurately, presumably it would have been even more accurately 3. So that's what you do. You find the square root of one, you find the square root of the other, and you times by the cos of the angle in between. Now, bear that in mind because we are going to use that quite a lot in what we do. 3, there you go. The second formula that we have, though, then this is a very much more useful formula, says that A dot B equals, now notice this, you do the top one times the top one, the second one by the second one, the third one by the third one. So write that down because that's a second equally important formula. Probably need to pause the video to write all this stuff down. It's a lot coming at you fast and furious. But when you get that, and you've written all that stuff down, you get examples like this, which are really okay. It says, given that vector A is this and B is this, and the angle between them, they tell us as well, it's and they want us then to find A dot B. Okay, so first of all, the rule says up here we need to find the magnitude of both vectors. So let's find the magnitude of A, written usually with the 2 lines around it. So you do Pythagoras, it's 2 squared, ignore the minuses, plus 1 squared plus 3 squared. That's root 14 if you do it. And what's the other one? Magnitude of B is the square root of 3 squared plus 4 squared plus 1 squared. Again, ignore the minus. What's that? 9, 10, I think that's 26. Now, on that basis, then, I can say that A dot B is equal to root 14 times by root 26 cos of this very precise angle, 74.81. And I suppose it's no surprise that the angle between two vectors is not particularly necessarily a nice answer. So let's do this. It's root 14 times by the root of 26. Make sure you get out of that. Then times by the cos, and again in degrees, 74.81 degrees. Yeah, I've typed it in right. 4.9999. Lots of 9s going on there. Presumably 4.999, if I did the angle even more accurately, would be basically 5. So it's approximately to 5 to 1 day, for one significant figure. Oh yes, I've written 5 here as well. So I mean that's a good example of what we're trying to do. We find the magnitude of one, the magnitude of the other, and you can, as long as you know the angle in between, you can work out A dot B. There's this second formula though, which is equally, if not more useful than the first one, and you can find A dot B just directly. And notice this is perhaps more like you would expect the formula to be. I at the start did an example of a formula I would make up. But this is similar to it. You basically times the top 2 numbers together, then the second numbers together, then the third ones. But notice you add them up as you go along. You don't put them into a new vector, you add them up. And bearing that in mind, let's go back to the example we just had. A dot B here, and these are exactly the same 2 vectors as I just showed you, times the top 2 numbers together, 6, plus minus 1 times by the 4, plus a minus 4, plus minus 3 times minus 1 is plus 3. And 6 take away 4 is 2, add 3 is 5. Yeah, and look, 5, that's what we had before. A dot B is 5. And it doesn't matter which method you use, theoretically you get the same result. And in reality, you very rarely know the angle in between. And this is a method then for us finding the angle in between. Here's another example. What's U dot V in this case? Well, 2 4s are 8, plus minus 1 times that is minus 2, plus 6. That sounds like 12 to me. And 12 is the answer. Okay, this is relatively easy, isn't it? Given that these, this and this, find A dot B and explain how you know they are perpendicular. Well, I should point out, this is important. A dot B, remember, is mod A, mod B, cos theta. Now, if they are perpendicular, and perpendicular means if theta is 90, then cos theta is cos of 90 is 0. And of course, if this is 0, when you times it, a dot b will be 0. So that's our rule for perpendicular vectors. So we have got to do this, and basically if we get 0, our vectors must be perpendicular. So let's just see what we've got. We've got a equals 1 minus 1 minus 1, okay, and b equals 3, 4 minus 1. So let's do it. A dot b equals 1 times 3 is 3, plus minus 1 times 4 is minus 4, plus minus 1 times minus 1 is plus 1. Oh yes, it does equal 0, therefore they are perpendicular. That's how I want you to do these. Okay, what have I got? I've got the answer here. A dot b equals 0, therefore this equals 0, therefore cos theta equals 0, therefore it's 90 degrees. There you go. Finding the angle. This is the main point of doing the dot product. You get loads of questions in exams. Find the angle between these two vectors. So what do? Well, we effectively use this formula. And of course there's two ways to work out a dot b. And we combine the two formulas together, and it allows me to rearrange it to get cos theta. Again, write it all down. This is important stuff. Here's an example for us. We've got a vector A and a vector B, and it says if the scalar proctor is 0, remember the vectors must be perpendicular. Okay, we'll find it. If it's 0, we'll know it's perpendicular. I want the angle, so let's go for it. So my first job is to write this down, as I personally would write it as a column vector. 1 minus 1 minus 1. This is what we just had, I can't remember. B equals 2, 1 minus 1. So A dot B equals times 2 plus a minus 1 plus a 1. Yeah, so actually it's equal to 2. 2, that's 1, that's 2. A dot B is 2. So it's not perpendicular. Now let's find the magnitude of A and the magnitude of B. Magnitude of A is the square root of 1 squared plus 1 squared plus 1 squared. Even I can do that in my head. It's root 3. And you might as well leave it as root 3. Magnitude of B is the square root of, we've got 2, 1, 1. So it's 4 plus 1 when I square them. That's root 6. And therefore, this is the trick. You now write cos theta equals A dot B, which was 2, divided by magnitude of 1, magnitude of the other, root 3, times by root 6. And let's type that in and then inverse cos. So what have we got? 2 divided by the square root of 3 times the square root of 6. I get root 2 over 3, and I'm going to immediately just go inverse cos of the answer equals. This implies that theta equals 61.9 degrees. Well, that's what I get anyway. 61.9 degrees. Find the acute angle between these. Oh, right, if you ever get lines, now of course we've talked about these before, these are equations of lines, but they have direction vectors. And you might be thinking there to yourself, which ones are the direction vectors? Well, it's always the ones that which are attached to the lambda or the mu or the s or the t. So my first direction vector is minus 2, 2, 1. My second direction vector is 6, 8, 0, 6, 8, 0. And I need to find the magnitude of those. So magnitude of D1 is the square root, square, square, square. That's 4 plus 4 plus 1, which is great because that makes 9. And square root of 9 is 3. It's perfect. This one is the square, oh, I should have written, and this implies that the magnitude of D2 equals the square root of 6 squared, which is 36, 64 plus 0. Oh, that's root 100, and that's great because that's 10. Now I'm going to D1, D2 them. D1, D2, just very quickly do it. Minus 12 plus 16 plus 0, that's 4. So therefore cos theta is A dot B, it said, so that's 4 divided by 3 times by 10. So I'll quickly do that. And inverse cos the answer, I get 82.3 degrees. 82.3 degrees. Look at that, it's even worked. Warning, I'll go through this example in the class because it is a slightly different one, and I'll do that, but then that's it. That's exercise 2D. Be aware this is exercise 2D.1, so there's another one coming as well. So thank you very much. Goodbye.